Hello. Am I audible, sir?
Yes, sir. Yes, sir. You are audible. Can I, sir? You are audible.
Okay.
Can we start?
Yes, sir. We can.
Okay.
Yeah.
Can you give me a sharing option?
Yeah, I will. Yes, sir. Now you can share.
Okay, thank you very much. Okay, so thank you very much for coming for the session. We are nearing, only 2 or 3, I think, today designed for X. When you have project management and the human side of project management. So typically 3 sessions, including today's. So we'll be finishing this. So it has been a great journey. And thank you for your attention on a Saturday, coming and really listening. There is a saying, when there is a stage, the stage is not existing because of the stage, but because of the people who give respect to the stage. So that's the beauty of what we do here. So thank you very much. So any comments from the previous meeting? Anything you would like to share? Any experience? Any change that you have brought about? Or anything that is useful for others to hear? Please do. Yeah.
Sir, in the last meeting, what we saw the new thing about software development protocols, basically, in our layman language. So many of us didn't know about the theories behind software development. So we got to know details about software development. That was the say key point for the last session.
Thank you. Yeah. So will you be, of course, people come from different specializations and areas. So eventually, everyone has to more or less know what software development is. And you cannot see my screen now? You can?
Yeah, we can see.
Okay. So we need to, eventually, that's my belief, okay, that software will become pervasive everywhere, just like AI will become pervasive everywhere. So it's good to learn. So in fact, yesterday I was having a research, project proposal preparation meeting with School of Nursing in National University Hospital, the psychiatry department, the medical department, engineering, innovation, and AI is becoming dominant and prominent and being used everywhere. So it is important to know how to program. So I would like to position that way. So today we will move on to design for manufacturing. But we went through the design for software with design for or design for software development. It's a process which can help software engineers to create high quality, maintainable and reusable software. When software can be reused, we will reduce the software development time. So you need to have a systematic approach to software products. So in order to have the design for software engineering, there are several requirements, methodologies, and practices, and also have to consider the constraints. So the aim is to create a design that facilitates the software. So here the right side, I hope you may be able to read it. So you need to gather the requirements, design the system, and have a detailed design, implement, test, deploy, and maintain. These are all the stages. We have seen that in the previous week, but just to recollect, to really align with the design for manufacturing, this is put. So requirements, what are the requirements of the software? And here, sometimes I see softwares which are not user-friendly. So the other day I was talking to someone. There are a lot of enterprise resource planning softwares, costly ones, millions of dollars, and annual maintenance contracts will involve a lot of money. The reason is when they develop, they write down the stages of use or different steps involved in the use of the software from the standard operating procedure or process that they think they need to do. See, even in banking, it's there. And sometimes I feel really frustrated. Why some softwares are written in this manner? They don't have any idea about the pains a user goes through. So the user needs or the stakeholders' needs are very important. And we need to know how a stakeholder will be using and what are the functional and non-functional requirements. Certain things the users need not have to know. So even in websites, there is so much information just dumped there. How much of that is readable or how much of that is read? People don't read these days much. So you have to be very careful about that. So the needs of the users or stakeholders are most crucial, and how they will use. And again, there are young adults, teenagers, adults, aged, and senior citizens. They'll be using people with different capabilities. And how to really make the interactions most enjoyable. And I can say that, to be frank with you, I feel very frustrated to use some of the banking softwares from India. And I don't know why they have designed in that manner. No use for me. And so many things are there, and I don't really understand. So when you do transactions, NEFT, quite a number of options are there, but they don't give explanations. And if I have used some method, why not? That is naturally being the choice for me to do the transaction. Why are they giving so many options for me? All the time I have to click, 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 click. That's not the way. So there are quite a lot of things required in terms of users, and AI can help a lot, but we are far away from even making the software, some of the softwares, whether costly or not costly, softwares user-friendly. And that user-friendliness is the most crucial part. So while that is kept in mind, the architecture of the system is software system to be understood, not the other way around. The architecture should not, dictate the user interface. Architecture of the software is meant for the software to work, but the user interface is meant for the users. So what are the components, how they interact, and how data flows between them, among them to be understood. Then go to the detailed design, individual components, specifying the interfaces among the components, and algorithms used, data structures used as well. And then for implementation, the coding is required, and then testing is required.
येत नाही
Yeah.
सर.
1 minute.
Pradeep Jadhav, sir. Pradeep Jadhav, sir.
Oh, okay.
Okay, yes, ma'am. Yes, ma'am. I will.
Muted. Okay. Testing, of course, that is required. And I mean, almost all the systems are tested, but they test, who will test it? Is it user-friendly testing and or functional testing, and then deploy and maintain? This is what we have seen. Okay. So again, I wanted to really connect with the design for manufacturing. So I reiterate this software development related aspects. So there are principles to follow to optimize the development process, improve the code quality, and enhance maintainability, and be able to streamline when future updates are required or enhancements are required. Ultimately, designing a software with the development process in mind contributes to more efficient, effective software development, which will have better quality. So modularity and componentization are very important. We mentioned about modularity before, how to scale from 10 users to 100 to 1,000 to 100,000 to 1,000,000 or 1,000,000,000 users, and will the performance will be maintained, and how to maintain and make it extensible, follow coding standards, design patterns and principles, and clean, modular, well-documented code. And most times this is not properly done. Then somebody leaves the organization, someone has to continue developing or testing, will be a difficult task. So there are a lot of software development tools available as well. Test quality assurance, so unit testing framework, mock objects and code instrumentation, integration, interoperability, user interfaces, and design. So these are what we have seen. So design for software engineering is a complex process, valuable tool, and we can create, and by following the process, engineers can create high quality, maintainable, reusable software products. So there are benefits: improved quality, maintainability, so reusability is a valuable tool. Okay? So that's what we have. Now, with that, we have to move forward for design for X topics. Design for manufacturing, design for product. This is the hardware part. Design for assembly, design for recycling, design for disposal, design for life cycling, and also about prototyping. It's a set of design principles and methodologies so that you can optimize various aspects of products life cycle. So design for manufacturing focuses on designing products with manufacturing processes in mind. So when I started my first company in 2004 and expanded to India to release floor cleaning robots in India in 2008-9, we were the first to introduce that, as I mentioned before. we didn't have any idea about design for manufacturing. So whatever we design, whether mechanical, electrical, electronics, or embedded software, it was for making a prototype, a functional prototype. And then my co-founder student went to China. Of course, there was a interpreter. And then he spent there almost more than a week time to understand the design for manufacturing or manufacturing processes. And they gave a lot of inputs to him. And he showed our design to them, and they did not accept those. And they mentioned that you have to completely change. And you have to each and every aspect, what is easy to manufacture, how to reduce manufacturing time, very important in all the processes. We'll see some examples today. And then they need to reduce the bill of materials, including time to manufacture. And then how easy to manufacture and ship. That's the important part of it. So it's not manufacturing alone, the assembly part also. So we'll see some examples what to avoid, the do's and do nots. How to simplify and optimize some processes. And I think if you look at it, I was quite impressed. See, my house in Kerala is a very traditional house with the tiles and all wooden ceilings and structures. And I renovated in a major manner. It's almost 160, 180 years old. So 20 years back, I renovated it completely without using concrete and other things in the traditional way. And when I was interacting with the carpenter, the traditional carpenters, family, father to son kind of transfer knowledge, they don't have any degree. But I was quite surprised that can you mute that? Anil Landgate, Dr. Anil Landgate. Can you mute? I cannot mute it. Can you please mute?
Any question? Landge sir, any question?
No,
Landge,
Vidyaji, you can,
Yes, sir.
No, madam.
yeah, you can mute them.
Yeah.
Okay, thank you. Yeah. So I was talking about these carpenters. I was quite surprised. I suggested a major change in the superstructure of the kitchen dining area. Traditionally, there were quite a number of partitions, and I want to remove a lot, keeping the major structure intact. And, he doesn't have to look at computers. He doesn't have to have paper and pen. It is there in his brain. And he was using some Sanskrit shlokas to really talk about some of the things. And he said, I can do this. This is the way it has to be changed. Then it will fit in. And then I observed the way when they started working. And they have very tools to as far as the lengths of all the main beams and sub beams are concerned, the wooden structures, and at the corners how it will be cut, and it is very clear. He was not looking at a design paper or printed one. It is in his brain, and everything was fitting in. And then he was saying, when you put the superstructure in a particular manner, triangular, trapezoidal, three-dimensional space, on top of it you have the tiles paved. I mean, that is considered as an auspicious time, and they do some puja, and we say the main carpenter, there is a name for that, and he goes on top in a particular way, and then he gives instructions and everything fits in just like that. And without a support, it will fall. But the moment everything is fitting in, it fits in. So that is optimization done long back when it comes to the manufacturing processes for traditional houses in India. Definitely, we don't really appreciate it. We don't teach about it. I don't know whether it is being taught anywhere, but we have to really appreciate it. We have to really understand it. And I brought in my, from NIT, Calicut, National Institute of Technology, Calicut, Kerala, architectures to really observe this. And they were so impressed by that. So we need to really appreciate time-tested optimization tools designed for design aspects and how the optimization is done long back.
Correct.
All right. So design for manufacturing focuses on design products with manufacturing processes in mind. My founder went to China to learn that. And it is to optimize the design to improve manufacturability, reduce production costs, because without reducing the production costs, we cannot reduce the bill of materials. If you cannot reduce the bill of materials, your profit margin will reduce. So we need to optimize, improve the profit margin. Then only we'll be able to make the product attractive to the users. They can buy it. More people buy, more profit. It is scalable and sustainable. So all this have to be seen from the totality point of view. So what is what material to be selected? How to simplify the parts? We'll see that. How to standardize the parts, and what kind of design for automation is required. So eventually, to reduce the production costs without sacrificing product quality. So how do we go about doing it? So you have to gather the information, sketches, drawings, product specifications, and possible design alternatives. Now you recollect the concepts we designed, concepts, design, and selection, testing. So there may be alternatives. And something which you have selected may take more space to include in the overall system, and that may impact the design of something else or manufacturing of something else. So you need to really look at the design alternatives. That's why you have to maintain all the designs that you have gone through. You may pick a part of it from somewhere and reuse it. And most times, manufacturing is done somewhere else. Now, India was not good at manufacturing processes, but now India is leading, including Apple iPhones being produced in India and sold across the world. And this is very important. And I think our engineering education has become more biased towards software IT sectors because the number of jobs created was very high. But now,
especially during the COVID situations.
Yeah, correct. Yeah. Sorry, Vidya ji, can you repeat that?
I'm saying especially during the COVID situation.
Yes. Yeah. And now I think with more manufacturing making in India, Stand Up India, Atmanirbhar Bharat, I don't know, I think I might have mentioned this to you before, that 60% of part of a product should be made in India. That's a goal, and eventually more and more. So there are think tanks for the central government trying to understand each and every product. They take one product at a time, how much it is done in India, how much is done abroad, and how much step by step more can be done in India. So my son's company got very big projects from Indian Navy because of this. And they allowed the company to really license it or make it more. And that's the way we have to really grow. And I mean, it's very important for educators, not only, the political think tanks to know about this. We need to know, to have educators across board at different stages to really impart this information to our students, so that they will become part of the nation building. And that knowledge is very important. That's why, this course is very important. Most times I've seen a lot of debates happening. The cost of something is high, or why Adani, it was Birla and Tata. Now, that is purely the size of the market, the scalability of the market, and the sustainability. So, for example, 1 rupee collected from everybody in India is going to make billions of rupees. That's the size. Our size is so big. India is has crossed China in terms of population. It's a very big market, and it has got available at a very affordable price. You don't see that everywhere. And smartphones, cheaper ones and affordable ones, and QR codes and digital payments, it is going to really unleash the potential. And to be frank with you, during COVID, I did not visit Kerala and India, almost 2.5 years plus. And my frequency reduced a lot even afterwards compared to prior COVID. But I have seen tremendous change in the society in terms of empowerment of women, empowerment of children, empowerment of aged people, empowerment of families, empowerment of communities. Of course, a lot more to be done. So we're all contributing to that nation building. So excite people, excite yourself, excite your colleagues, excite your students, your management, or whichever way, to really being part of that nation building. Okay? So, of course, we can make costly products, and for that, a lot of money is being spent, but that money is being collected from people. But if you reduce the cost of that and call it without sacrificing quality, more people will buy. So you need to estimate the manufacturing cost, production volume, and ramp-up timing. How you to do that? So this is an input-output model of manufacturing system. It is, table you can create and capital consumed by each of the production process. So you can have an input-output matrix. Okay. Also show the goods and services produced from the system. So this model analyzes the physical quantities produced and consumed in each sector or each process for each process, and able to determine the resource allocation to reach certain balance. And then you have to really divide the manufacturing cost into component costs, assembly costs, and did not change much. And he's taken care of his family, the children's education, marrying his daughters off, and still leading very well. And when we sell a banana bunch to him, and if I buy back immediately within 1 minute, the cost will increase. That is because he has to pay the rental, he has to pay for the utility, he has to pay for a helper, So we need to understand that cost. So direct material costs, cost of raw materials or components directly used in the product manufacturing process, cost of purchasing, producing the materials. So the components can be standard, you buy off the shelf, or custom, where you have to have raw materials. These raw materials have to be processed, and then tooling is to be done. And of course, there will be costs, additional costs for storing, handling, processing them. Then direct labor costs, that's workforce required, wages, salaries, benefits, other expenses associated with the labor to assemble, operate machinery, perform tasks.